Welcome, everyone. We'll get going at noon. We just got to give a little time here for folks to get logged into the system. While we're waiting, I really want to thank all of our presenters today who've really gone out of their way to and have been thoughtful about their presentations. I think you will enjoy this webinar. Welcome, everyone. We're just giving a few minutes for Zoom to let the 100 or so folks that are registered for this webinar get into the room. All right. Still have some folks logging in. Give it one more minute. All right, I have 12:01 and I'd like to get going because we have a lot of stuff to go through and we are hoping to have some time at the end for some back and forth questions and answers. So welcome, everyone. Thanks so much for joining us today. I'm Janine Burke-Wells with NEBRA. Just some quick Zoom guidelines. I'm sure everyone's used to it now, but you will all be muted as you join. And I ask that you just stay on mute until the end when I can open it up for discussion. I'll ask you to use the raise hand function there at the bottom of your screen. And if you would like to type in questions as we go along, that would be very helpful. Go ahead and enter a question in the Q&A. I'll be keeping an eye on that. So this session is being recorded and we'll get you the slide deck and the recording after the fact, and it'll be available to everyone from all the NEBRA members on demand. Several of our members asked us to pull this training together with all of the focus on PFAS-contaminated farms in Maine. Farmers all over the region and the country have a lot more concerns and questions about using biosolids for soil amendments going forward. So talking to farmers about their concerns doesn't have to be scary if you have a good understanding of all aspects of the PFAS issue, what we know, what we don't know, and you understand what's important to individual farmers. We don't pretend to have all the answers, but we hope to give you the information and the confidence you need to talk to farmers about this very complex and sensitive issue. So today you will hear from several speakers with various perspectives on the topic, including a wastewater treatment facility operator, a farmer, a regulator, and an advocate. So first, to kick it off, I would like to introduce Nick Champagne, ask him to turn on his camera and microphone and grab the screen. Nick is the superintendent of the Kennebec Sanitary District in Waterville, Maine. He took over from longtime Superintendent Timothy Lavasser in January 2020. He's a graduate of the Civil and Environmental Engineering program at the University of Maine and a licensed professional engineer. He has over 10 years of experience as a consulting engineer focused on water utilities. He previously worked for Woodard and Curran in Portland, Maine, and A.E. Hodgson Engineers in Waterville, Maine. And he was also previously the city engineer for the city of Waterville. Nick, thank you so much for taking time out of your nonstop day to join us here and set the stage. Take it away.
Thank you very much for the introduction, Janine. And Janine asked me to talk here today in regards to my perspective as a facility manager, Kennebec Sanitary. Of course, many of you have seen the news out of central Maine in regards to PFAS contamination as a result of the state of Maine's efforts to test in the central Maine area. And I thought I'd just kind of walk you through the situation that I kind of took over in January of 2020. That's just a little background on KSTD. I'm not going to read through word for word, but the treatment facility in Waterville went online in 1976. We serve 4 member communities, City of Waterville, Fairfield, Benton, and Winslow. And we also have one significant industrial user, Huhtamaki Incorporated, formerly Kai's Fiber, paper product manufacturer. They contribute about 30% of our flows and about half of our BOD and TSS floating. We average about 6.8 million gallons per day to the Kennebec River. And we dispose of about, currently of about 8,000 wet tons of biosolids per year. And just a background on our biosolid disposal. So from 76 to about 82, the district had its own landfill that it disposed. Volume restrictions, of course, shut it down. And in that point in time, they investigated and pursued licensure from the Maine DEP to land apply biosolids at approved sites across central Maine, those being in the towns of Fairfield, Benton, Albion, and Unity. And since 2003, we have an agreement with Casella Waste to haul our waste to landfill, with a portion going to Hawk Ridge Compost Facility in Unity. And so just keep in mind that I started in January 2020. So of course, it was right before the pandemic. But just to give a quick timeline on PFAS testing in Fairfield, I just have to note that March 2019, Governor Mills signed executive order for a PFAS task force. And that kind of evolved into 2020, some sampling of milk on a Fairfield farm. And at that point, it was indicated there were some high levels, and they expanded testing to site soils and wells on that same site. Spring 2020, state finds high levels of PFAS in wells on the farm site, and they expand to further wells adjacent and nearby properties. And from summer 2020 to about spring 21, the state found high levels of PFAS in wells adjacent to the site, and in addition to another location on the northern side of Fairfield, adjacent to another paper mill, that being Sappi, located in Fairfield, Skowhegan area. Several residents at that point in time were issued do not drink orders. And in summer 21, the state indicated to me that they've expanded to all sites that KSTD has land applied. And they noted a couple high levels, but certainly not to the levels of Fairfield in Benton and Unity Township as well. What I want to point out is that this information came pretty quickly. And of course, in early part of 2020, my focus certainly was not on PFAS. And obviously working on the pandemic and dealing with those issues, supply chain issues and whatnot, PFAS was not on my radar. The biggest thing that I want to point out is that the information comes fast, and what you need to do is you need to be prepared on understanding the biosolid land application sites that you have. Again, being new to the facility, really had to go back in and understand our waste sites, and also review and understand your waste sources to your facility, both past and present. Keep in mind that KSCD has not land applied since 2003. So I really had to go back into our records. Review and organize biosolid land application files if they're still available. KSCD did have those. We did get FOIA requests, so be prepared for FOIA, Freedom of Information Act requests. We had a dated policy that we needed to update. We've received about 3 or 4 different requests over the past couple of years to have a look at our files. So think about the logistics of that as well. But the biggest concern is being prepared for questions from the press, public officials, and other interested individuals. Mostly, I had the town manager in Fairfield asking me a lot of questions that I was not prepared to answer. And having a fact sheet would be extremely beneficial, especially just kind of outlining land application for your site at that particular time. And keep in mind that in this age of technology, misinformation can spread quickly. And what we found through this whole process was that without having the facts put forward, conclusions were drawn based on information that just wasn't true. Having that fact sheet that you could prepare for a reporter or for public officials certainly helps thwart the accurate reporting of what's going on at these sites. So just keep in mind that we are industrially impacted. Like I said, Huhtamaki contributes about 30% of our waste. Anyway, I just wanted to point out that just be prepared and understand your facility's history. Any questions at all, feel free to reach out to me, and I'm going to hand it over back to Janine. I don't know if you wanted to continue that. Okay.
Yeah, thanks, Nick.
Sure.
I am just going to spend 1 second here to talk about why it's such a challenge to communicate about these issues. And this is something that I adopted from the Interstate Technical and Regulatory Council. So the problem with talking about contaminants of emerging concern like PFAS are many. For one, regulatory programs are confusing because they're not consistent and they vary across states, causing a lot of concern and confusion. The fate and transport, as you will hear, this is very complicated stuff. The toxicological and epidemiological, there's lots of unknowns, there's gaps in research there. And unlike other pollutants like lead, for example, I think of there's that chelation process where they can actually reduce the levels in your blood. We don't have anything like that with these compounds. A lot of technical issues, trying to ID the sources and figure out the best way to destroy them. Still have a lot of limitations with analytical abilities and the ability to measure, confidently measure the concentrations of PFAS in different materials. And then finally, quality of life issues is what we're experiencing in Maine. And that is a very real and tough challenge for communicators. So next up, we are going to hear from Gene Barker, who is currently a project manager with Casella Organics. I'm going to ask him to turn on his camera. And hi, Gene. I'm going to let him tell you a little bit more about himself and his experience and background. Take it away, Gene.
We'll see how it goes here. Shit.
There you go.
Okay. I'm gonna move this over here. Okay. Here we go. All right. I grew up on a dairy farm in Leeds, Maine. Worked there from the age of 6 up through. My family has been farming there since 1890, 6 generations, and we just heard that there's going to be a 7th. I don't know whether they will be able to farm or not. Currently, the farm has 300 dairy cattle. They grow hay, barley, oats, silage corn, and corn grain for sale. We've been using biosolids for over 30 years with very good results. It has helped the farm by providing nutrients to cover a ground that we didn't even have enough manure for. Most farms don't have enough manure on site to do their, to cover their fields, hay fields or corn. So we usually we used to bring in 100 loads of chicken manure from decosters every year, as if we could get it, to do corn and hay ground. A lack of nutrients, like I said, is a common problem, and I find it on organic and conventional, more so on organic from what I've seen. I've been doing sales, organic sales and conventional farm sales for 12 years, and that's my experience. On our farm, unfortunately, biosolids won't be used this year. We've decided not to spread at Lopka. For the last 12 years, I have run the program for them, along with Jeff Brink, who's moved on to New York now. But this year, nitrogen has taken a heck of a jump. It's gone to $15.50 a ton. Last year, it was selling for $600 a ton. This year, it's going to cost us $59,000 just to get starter fertilizer. And that's not including the spreading cost, which are quite expensive to run. fertilizer's gone up, bale wrap's gone up, everything coming into the farm. The inputs has been right through the roof. Everything's pretty much doubled or more. The biosolids are definitely a better alternative. When the PFSA mandate hit us, we were involved very, very fast in the issue. And my brother was cut off for 19 days with no milk market, which was quite hard. And so we went through the testing and everything before anybody really, and we were guilty until proven innocent, as it turned out. We went through 2 tests for our milk, which turned out to be non-detect on both, and we continued to farm, luckily. In my work at Casella, the phone started ringing immediately the next day after the mandate, and everybody was asking, what is this thing? What is it all about? It brought many unanswered questions. I couldn't answer all of them because we just don't know yet. I'm going to list on the what I'm going to do is I'm going to go through some of the questions, probably the top 12 that I've gotten from farmers. And the next slide lists some of them. And then I want to just mention a little bit about how I've talked with farmers about this, because I've been doing it for 3 to 4 years now. We knew about this before the mandate and we were talking about them, but nobody was really ready to listen then, way back. They are now. This is what is PFAS? How does it affect me, my family, and neighbors? How do I know I have an issue? They're running scared. How do I do PFAS testing? Should I do PFAS testing? Water for the soil, for feed? What does it affect? Where can I get more information on the PFAS chemicals? How do I know that my sprays are safe? What are the scientists saying? How do I know there is PFAS in the products I use? Is commercial fertilizer safe? Has anybody tested that? How about the sprays that we use? What do I tell my customers? I'm losing sales because they hear on the radio and stuff that this is bad. My neighbors are asking if what's this all about? Why doesn't Maine DEP and the Department of Ag say more of what they're doing about this? There's been not much from them at all. I understand they're under a gag order right now. Test results. The test for we have turned in tests from all the Lopka farms that we have spread for and tested the high fields and everything where we had spread, and they all came back low. They're asking why 2 years and we still haven't heard from the Department of Ag or the DEP, and no standard. What is the standard for this? Because we're getting these tests back and we don't even know whether it's good or bad. We're just going by what the state tells us. This has been around since the 80s. And that's another thing. This mainly happened around the 80s, 30 to 40 years ago. Why don't we know more about it now? Parts per trillion. What does this mean? You know, how much is a part per trillion? I don't understand how something so small could be an issue. Why is there so much misinformation in the newspapers? Why was what you're telling me different from what I'm seeing in the papers? I don't dare to, this is from a farmer just this week. I don't dare to speak up because I can lose my customers even if they think I might use a product with PFAS. I've had numerous farmers tell me they've lost hay sales, beef sales, vegetable sales, even though vegetables don't get coated with biosolids. They've lost sales. When the state put out that thing from the Department of Inland Fisheries, I had calls right off the wall, and I'll tell you more about that later. What can I do to limit the exposure to my family, customers, neighbors, and farmland? The farmers are concerned because they're not out to pollute their ground, despite what people think. They're not out to spray more spray than what they have to, or anything like that, because it's a waste of money and it's not good for their land, and they do care about their land. These are just a few of the samples and, and stuff I've gotten and comments that I've received from my customers and other farmers around. I'll talk to any farmer that calls me because I want to educate. That's what I've been doing for the last 3 to 4 years. I tell them we are far from all the answers to these questions, and we can answer what we know, but we'll try to answer some more of these questions today in this webinar for people. And it changes daily as we know. And another thing, before we do though, I'd like to offer a few points and facts about your audience asking the questions. The Maine farmers or any other state farmers. This is a countrywide thing. Before you start throwing facts at them, ask what their concerns, fears are about PFAS. Write them down. Really listen to your farmer, to what they're saying. Many are scared and upset at first before they talk to you. When they call, I've talked to farmers from the other night from 8 to 10 because they were so upset. Many are scared and upset at first, but we need to be able to calm their fears with the best information we can to help them. Let's see, is that going to flip? Here we go. When in person or on a Zoom call or anything, look them straight in the eyes when you talk. They're going to know that you're telling them the truth, because if you look away, they're not going to believe you, because they don't believe you if you're hiding something. Yeah, understand, ask them if they understand what you're saying or need more explanation. It's pretty complicated to absorb this stuff, so you have to really go slow with it. Understand that many have already lost farm sales due to newspaper articles or posted information that didn't have all the facts. Be aware and sympathetic with feedback from the farmer. Don't go down the negative rabbit hole, because some people like to run that gamut. Try to keep your answers upbeat and keep it positive. Understand that farmers have other stresses on their lives going on at the same time. Examples, the next grain bill, raising cost of inputs, or even trying to get ready for spring planting. There's a lot of cost involved in the spring planting just to get equipment ready. Fuel costs have gone through the roof. It's going to be a hard spring for them this year. Discuss cooperating with DEP testing or not. Now, I've had to do this with a lot of my Lopka farmers, and some of them were pretty uptight about the DEP coming. The last thing they want to hear is I'm from the government and I'm here to help, because they usually get screwed. And that's the truth. Now, I don't go along with that thinking, because I know there's some damn good people at the DEP that work out in the fields, and I've had excellent results with them through the last 12 years. I don't always agree with what they say, but they're following the rules, and it's for a reason. And they explain that to me, and I've had very good luck with that. I've found that trying to explain the procedure of who, what, when, of when the visit will happen of the DEP testing, and explaining to them what's going to happen before, it really makes them turn a no, I don't want them on my farm, to a yes, in most cases. Letting them know that they will get the results back from the test, letting them know that they're going to try to keep it somewhat, they're not going to broadcast their name in the newspaper, they're going to, that doesn't cost them. They're really there to help this time. So that's good. I suggest learning about PFAS to the farmer and giving them, enough so they can talk to their customers and their neighbors and friends, and give them a really good, comfortable discussion of the facts. I like to give them handouts and links to info. But you gotta know what you're giving them that is correct and truthful. Example, the Maine Inland Fisheries Wildlife. They put that out. They put that ad in the paper of all the Maine towns that were polluted, so-called. What they put in the paper was a list of all the licensed sites with towns with sites. They did not say whether they were spread or not. On this example I have of Limerick, there's a farmer in Limerick who was affected, lost beef sales because of this. And he had a field that was licensed by Portland Water District that was never spread because the town put a moratorium on spreading. And in order to do it, you had to give a great big amount of money, a big bond you had to post in order to spread in that town. So nobody ever did. But yet he got crucified because and lost sales because they put that information out without checking it out. And also the biggest thing is let them know this changes weekly sometimes. I mean, it can change from 1 minute to the next really quick right now. And lastly, allow time for to get the discussion in or offer to continue after they've digested some of it. It's a lot to swallow. I usually give them my phone number, and I said, give me a call. I don't care what time of day. I work 24/7. Call me anytime. And they do call late, but I don't mind. It's important that we get this out. And I can't stress that enough to you people, that you've got to learn, you've got to be factful, and you got to give them the best you can. And don't be afraid to tell them you don't know, but we can always get back to them. And with that, I'd like to thank everybody and Janine and the NEBRA for letting me sit in on this today. I've really enjoyed this. I think it's very important. And with that, I'll pass it on.
All right. Thanks so much, Gene. I'm going to ask our next speaker, Anthony Druin, to tee up his camera and his presentation. Anthony is the supervisor of the residuals management section at the New Hampshire Department of Environmental Services. And prior to his role as supervisor, he was the sludge and septage coordinator for the section. And before joining the DES in 2018, Anthony worked in the private sector as a senior project manager, running Class B biosolids and land application projects, sales and distributions of agricultural and landscape earth materials and site work projects. And he even spent some time doing research and development for a large paper company in southern Maine. He has a Bachelor of Science in Ecology and Environmental Sciences with a concentration in Soil and Water Sciences and a minor in Political Sciences from the University of Maine at Orono. And it was there at UMaine where Anthony was introduced to the world of biosolids through his research projects, and he hasn't looked back since. Anthony, take it away.
Thanks, Janine. And thank you all for attending this Lunch and Learn. It's definitely, I think, a very important topic, as right now we're seeing political environments change around this industry. And obviously, just like Gene was talking about, information that's being put out there, you know, there's a lot of different perspectives and opinions that have on this program or these programs. And I think communication is key. It's always key. And talking about these programs openly is, I think, the best thing that can be done, because when somebody is in fear of this program, if they think you're hiding something, I think sometimes that can be worse than anything. But I want to get into what we're going to talk about today real quick. Just going to talk about who we are, the New Hampshire residuals waste cycle, our PFAS collection system sampling we've done in sewer collection systems, the biosolid sampling we've been doing since 2017, other notable PFAS sampling events, the USGS PFAS sludge and soil leaching study that we're working with USGS on currently, and then the Northeast Biosolid Improvement Program, which is something we created a couple of years ago to pull together industry reps. So first and foremost, our section is within the Water Division within the Wastewater Engineering Bureau. I am the supervisor, like Janine said. Judith Sears-Houston is our permitting and enforcement engineer. Wade Pelham is our sludge and septage coordinator, and James Talvey is our inspector for sludge and septage hauling. As well, he inspects all our land application and facilities we permit in the state. So just a little background information on New Hampshire sludge, septage, and leachate in 2018. These were numbers I pulled from various different reports, but we had about 40,000 wet tons recycled to land application. These are wastewater treatment plants. We had about 50,000 wet tons disposed at landfill or in landfills in New Hampshire. And that's from New Hampshire wastewater treatment facilities. And then we incinerated about 17,500 wet tons. And that is one incinerator located in the center part of the state at a large city. We saw over 100 million gallons of septage managed in the state. We're seeing that year after year, and it is increasing. The population growth is increasing in New Hampshire, and these are private systems mostly. The southeastern part of the state doesn't have much infrastructure. So as that area develops from the Boston sprawl, most of those homes are being put on private wastewater systems that they have to run themselves and have pumpers come and pump every 3 to 5 years. We have 6 operating landfills in New Hampshire, which generate about 100 million gallons of leachate per year. Out of that, about 80 million gallons was managed in New Hampshire at wastewater treatment facilities, and then about 20 million was managed out of state. Those numbers are changing. This is 2018 and 2019. There was some press that went out, which kind of changed this management. So we are seeing more of our leachate managed in state today. But there is a chunk of this leachate being shipped to New Jersey for treatment because that was the closest facility they could find to accept their leachate. That's quite a long drive to treat water. So I want to get into our collection system sampling. This came about from our biosolid sampling. And what we wanted to do was help municipalities begin to identify any type of sources of PFAS coming into their collection system, whether it was industrial or residential. So, how we set this up was a volunteer program. We had interviews. We developed a sampling analysis plan. We went out and sampled, reviewed the data. Through our 2 sampling events thus far, we've just conducted our 3rd this week. We found that this is a viable sampling protocol and does yield some quality data, even though we are using a method that is in question. I think what we're looking at here is an investigation. So, when we talk about the data in this investigation, I think it should be taken as that. This is not to be creating any type of regulatory standard or influence that at all. Again, this was a program to be a volunteered program, not forcing any municipality or wastewater plant to do this, and really assisting them on helping begin to identify and set up a sampling program that they can run for the future. So here's a little snapshot of our TALV 2000. This is a great sample equipment that our inspector helped us modify and create so this sampling event could actually happen. First, we were doing composite samples, and we really found that was just too time consuming and too much of a risk for cross-contamination. So with that, we did go back down to a grab sample, but we feel, to get that snapshot in time, and again, for the investigative purpose, this did suffice. And what you're seeing here is an HDPE sample bottle kind of crammed into a stainless steel sample cup using HDPE caps that are actually part of a Biosolid sample container. And that really locks it right in there. And we were able to get that down into various different collection systems, whether it's a pump station, wet well, or the sewer main itself, and really have no fear of losing that cup. The only thing I was actually afraid of was losing the metal cup, which is just held together with those 2 pins. You can see this metal device really has no plastic, no rubber or anything on it. We really wanted to eliminate any potential cross-contamination parts of that sample equipment. Did quite a bit of sample cleaning in between every sample, and we've done an equipment blank at every single sample taken. I now do that for all my biosolid samples just to make sure that we're not cross-contaminating from our sample equipment. And especially when we're doing this type of sampling, we are we're doing multiple samples in one day. We're able to do actually 8 samples in half a day through this new revised method that the TALV 2000 has allowed us to do. So with that, I'm really confident that wastewater plant operators can go out and conduct this type of sampling and grab information that I think is viable and useful. We wanted to make sure that this type of protocol was something that wasn't intimidating for an operator, and also something that's achievable. So, it was tricky. We didn't want to go too hardcore lab on them, but we also wanted to make sure that all quality checks were made in consideration, and that QA QC was definitely top consideration when we were sampling out there. So just some information on what we've collected. So this is a community in southern New Hampshire that is impacted by PFAS by an industry. By just saying that, you might know what town I'm talking about. I am not going to label any towns today or talk about any specific municipality, but you can see here there's hits. In the top there in sample 1 and 2, and 3, you'll see that's kind of a residential background that we saw in this town. When we get down to samples 5, that was actually directly out of a facility that is known to be a PFAS contaminator in the community. So we found that to be very interesting, even though they're supposed to have a pre-treatment system on their line. And then sample 6 is actually the connector just outside this facility of everything north of that facility. So you can see, and that's a residential community above them. So you can actually kind of see the difference between what that industry was discharging on that day at that time versus what the residents north of it were discharging at that day at that time. That very large number in the thousands, that's a stormwater drain that's discharging from the parking lot of that facility. We were able to capture a low flow of water out of that stormwater drain. And when I talked to members of the Haz Waste community or Haz Waste Remediation Bureau here, they let me know that at that flow, most likely it was groundwater that we were sampling and not stormwater from the recent rain event that we saw a day before that. So thought that was pretty interesting. But definitely, you know, I brought that back to the agency here so people knew that we did take that sample and we saw that. And then you can kind of see here going down through, there was some other hits. And again, you can see that influent-effluent composite. Why is the effluent higher than the influent? Our suspect is that the oxidation occurring in the treatment process is exposing or cleaving or transforming our precursors, the precursors that are present in the wastewater, to terminal compounds. And that's why you tend to see this higher level in the effluent versus the influent. And we do see that, as you will see in sludge data, with looking at compost versus non-compost, and specifically in-vessel compost that sees a higher oxidation than other sludge treatment methods. You can see our field blank there also was 0, so that was nice. And all our equipment blanks in all this sampling were non-detect at 1 part per trillion. So we definitely were confident that we're not cross-contaminating here. Here's a second community that is north of this, this community or municipality, and this area is not as much impacted, and in fact doesn't have any known serious industrial contributors to PFAS in the community. And you can just see much lower concentrations, total PFAS to 0, and then the 4 terminal compounds we regulate in New Hampshire right now, mostly 0. Again, that influent-effluent difference there is something we see in all samples in New Hampshire taken at all wastewater plants. It's not surprising to us, but you can see there were some hits on the total, and then, you know, really nothing on the 4 compounds there. And again, this community doesn't seem to be impacted. Currently, this wastewater plant is sending their sludge to Canada for composting due to PFAS and a situation in town that happened where there was a site that had been deemed as a contributor to PFAS contamination in groundwater, being a land application site. So this municipality decided to remove themselves from the land app program and send their sludge to Canada. Here is our sludge biosolid PFAS investigation data. We've been conducting this since 2017. I joined DES in 2018. So 2017, 2018 was sampled by a different person, but 2019, 2020, and 2021 has been sampled by myself using one lab. So we are currently using Alpha Analytical because that's our contract for lab services right now. They won the bid twice in a row. So we've been able to use them for these 3 years in a row here. And as you can see, numbers are kind of everywhere. For us, when we sampled our paper fiber sludge, we found it to be a lot less than the other biosolids and obviously sludge there. Why I have the sludge up there, we have municipalities that are part of our sludge quality certification program, which is the certificate you must have in New Hampshire to distribute bulk biosolids. They are within our program, but they're not directly land applying anymore. They've kept their SQC for monitoring because they ship their sludge to a third-party composter, and they actually enjoy the fact that they kept their SQC so they can see their chemical quality data on an annual basis. So that sludge does turn into Class A biosolids that you see below. So there is a little bit of crossover here in this chart, but I'm going to break that up in just a second. And on the top there, you see drinking water residuals. We do have 2 plants that do recycle their hydrosolids to beneficial use. We do not allow direct land application of hydrosolids. We allow them to blend it into topsoil and make a manufactured topsoil as long as the arsenic concentration does not exceed 11 parts per million. I just want to make sure we're looking. So here what we have here is this chart is kind of getting cut off. But again, we're looking at the, oops, sorry about that. So right here is PFOS concentrations alone in the biosolids or sludge we've sampled. So again, we kept the sludge in there. You can see that some of that turns into Class A. But when we look at PFOS, there was a slight difference in 2017, 2018 compared to Class A. But really, when we get into it, there isn't much of a difference between Class A and Class B biosolids. We detect PFOS in biosolids about 90% of the time. So it is the most detected PFAS compound we have found in biosolids. And that's, generally the nature of PFOS. It wants to absorb the carbon, so it tends to make sense that you're going to find it locked up into the sludge. PFO, so what we do here is we remove the sludge out of the graph here to show you really what is truly land applied in New Hampshire. So you can see there is a little bit of a difference there, again, in that 2017, 2018 data. But again, as we go through the years here, there isn't much of a difference going on. Things are resting between 4 and 6 parts per billion for PFOS for the SQC biosolids. When we get into PFOA, you can definitely see there's a difference there going on between the Class A and the Class B. Makes you scratch your head what's going on there. So when we isolate out our static composted biosolids versus our in-vessel composted biosolids, we do tend to see a bigger difference there. And working with Dr. Mauser up at UNH, we started to review this data and understand what's happening here. And the hypothesis is that the in-vessel composting is introducing a lot of oxidation to that sludge to compost it, which is essentially cleaving or transforming the precursors that are not measured into terminal compounds. So what you see here is essentially those precursors turning into that measurable PFAS. So you're seeing the real PFAS concentrations there, and there potentially is a lot more in there that's not being measured at this time. But again, I just want to show you that difference of how oxidation of sludge can change and transform PFAS compounds in the sludge. When we do look at this, Class A biosolids do not require site permits in New Hampshire. Class B does. We tend to have Class B really only on farm fields that are for forage and feed cropping, while Class A biosolids tend to be used in more open areas like landscaping, golf courses, school, ball fields, and just general landscaping in general, and also home gardening. And there isn't as much restriction on the use of Class A. So definitely looking into this and how this is impacting our communities moving forward. Other noticeable sampling events. We did a rural septage lagoon solid sampling because they wanted to beneficially use it. They initially sent us out their data, it was sky high. It made us concerned. So then we looked at this more and we found that they were right. We did some composting toilet. This is directly human feces and wood chip. 13.3 for the total and then 9.6 for the 4. And this is all parts per billion, mind you. Elementary school, out of that rural community with the septage solids, we wanted to start looking at the septage that's being inputted, and specifically over 40% of the septage going into that lagoon comes from the surrounding schools. So we're interested in looking at how janitorial chemical cleaners might be impacting septage, and how does that directly impact wastewater processing and potentially sludge concentrations down the road. And then we had 2 aerated lagoon blankets we sampled that are going to be going through some upgrading, and we wanted to see what those values were. You can see there, present, and one lagoon had higher of the 4 compounds than the other. That one that was higher was more of a populated area and more of an industrially impacted area potentially. So, probably was it coming from there? We're not sure, but just there is a difference there. Just to quickly talk about our USGS soil and sludge leaching study. This is a 3-phase study. The first phase was New Hampshire soil background, where 100 samples were taken of non-impacted or essentially developed areas. USGS had to trek into the woods to take these samples. So they're very, we're confident that these are definitely soils that are representing, what is not seeing agricultural amendments or commercial impacts or industrial impacts. So, what we saw there is one thing you can see, it's 100% complete, and PFOS was detected in every single sample, at least 1 part per billion. The second phase is batch experiments on 5 well, there's actually 1 major biosolid that was done on the batch experiment and 3 soil types, but we did sample 5 major biosolids in our program and got a bunch of data that was analyzed off of that. That'll be used in the report that USGS will be writing. And then the third phase is our field investigative work to make sure that the coefficients that are produced in phase 2 are as accurate as possible. That has begun. We did, or USGS got out and completed the work at the AFFF sites. We are going to be doing the biosolid sampling this spring, just before the farmer plants. So with all hopes, the full report will be to DES this fall. Rule revisions I put in there was a question mark, but recently this has kind of changed. HB 1547 now is been proposed, and I think it's fully passed now, where DES has to come up with PFAS soil standards by November of 2023. From that soil standard, we'll back calculate a sludge standard for the SQC program. But that definitely puts a timeline on us to create a soil leaching standard that'll be applied across the state. Lastly, I just want to talk about the Northeast Biosolid Improvement Program we've created. This is a group that's pulled together industry reps, managers, residual managers, regulators, septage haulers, various people that manage sludge and septage in the communities of New England and the Northeast. What we've done is created 2 brochures for education outreach, 1 for residents and 1 for septage haulers and operators. The resident documents or brochure is going to educate the public on what is the impact PFAS has on wastewater, how does PFAS convey through the wastewater system, and how does it convey through our water cycle and eventually get to our drinking water through our management systems, whether it's landfill leachate, incineration, or land application. And then the septage hauler and operator brochures is to educate them on how to sample for essentially for PFAS out of septic streams coming in, because we're starting to see wastewater plants put in commercial septic permit programs that require sampling. So we wanted to educate them on the difference between domestic septic and commercial septic. So with that, I'm hopefully still within time, and we'll save questions for the end.
Yeah, that was great. Yes, thanks for that regulatory perspective, Anthony, and what you're doing over there in New Hampshire to make the biosolids better so you can maintain that land application program. Thanks for the questions, folks. Keep them coming. We're going to wait till the end to answer them. And our last presentation is a very familiar face, Ned Beecher, the former executive director for NEBRA. He's currently working for NEBRA still on various special projects, such as leading the National Biosolids Data Project and facilitating a project updating the BEAM greenhouse gas emissions calculator. He led NEBRA's PFAS work from the start. Thank you, Ned, as far back as January 2017. We've been talking about this. And he continues to track larger PFAS issues and consult with NEBRA on PFAS and biosolids issues. He's going to present some more research and health and regulatory perspectives. So take it away, Ned.
Great, thank you. I appreciate being part of this honorable group to present this webinar, and I hope it ends up being useful. I'll move through my slides fairly quickly, and hopefully we can have good discussion afterwards. So thank you, Janine, for organizing, doing a nice job on that. Thanks to all the other panelists for excellent presentations leading up to this. And all right, so our next this piece is about what we know and what we don't know. We've had a lot of regulatory news stories about farms and biosolids that have raised alarms and are sounding pretty scary. So, so we hope to provide here information that's useful to try to give a sense of what the risks are, how concerned we should be and how to address this and communicate going forward. So this is the outline of what I'll cover. What are PFAS? How are we exposed to them? Some human health impacts. There's some uncertainty around those. Levels in soils, waters, biosolids, and at some of the farms that have been tested. We'll emphasize that industrially impacted biosolids and situations are different from those of sort of the more typical background level biosolids and situations. We'll take a look at regulatory levels and then at what we can do. So what are PFAS? Well, per and polyfluorinated alkyl substances, much easier to just call them PFAS. They're pretty, it's a term that's pretty well known now and can be widely understood. It's a family of chemicals of as many as 9,000 of them now identified, and a lot is, they have this fluorine and carbon bond, which makes them or what they are, but they are of all different types and different subfamilies, and it's complicated. They don't necessarily all act the same way, and they don't perform the same functions. What they do share is they tend to be water soluble, so that means they can move with water, with groundwater, for example. But they also provide water resistance and grease resistance, and they bind to proteins. They are excellent surfactants, meaning that they will help chemicals spread out and can be used to create very thin coatings. And they're used because of those functions. So they provide that grease resistance and such. They are persistent in the environment. The fluorocarbon tail, or this, as shown in this diagram, the green and the gray, are carbon and fluorine. They're very strongly bound, some of the strongest bonds in nature. So they don't degrade, those fluorine carbon bonds don't break down in the environment. So that makes them fairly stable. And so what we've been using these for decades, and so what's gotten into the environment are sticking around. And that's why they're sometimes called forever chemicals, and makes them a bit scarier. There are two main original compounds called PFOA and PFOS. The O stands for Ocht, which is 8. So these are the ones that have 8 carbons in them. And anyway, these are ones that are most studied and understood at this point. It's important to discuss and understand what we're talking about in terms of the numbers here. So when we're talking about PFAS in waters, the general trend is to talk about parts per trillion. So the drinking water standards, for example, that are out there are talking about parts per trillion. Now, just to put it in perspective, a part per trillion is 1 second in 32,000 years, or 31,700 years, I should say. That's a tiny amount. So to be able to even measure these has taken great advances in analytical chemistry. And that's why this is a new and emerging issue. PFAS have been around for decades. They were invented in the 30s and 40s and have been used ever since. But we're becoming worried about them now and in the last 20 years or so, only because analytical chemistry allowed us to measure them in very different places all across the globe. So, but it's still a challenge for analytical chemists to distinguish between 1 or 10 parts per trillion. It's a very tiny amount. And in soils and solids, and often sometimes in wastewater and other materials, we tend to talk about PFAS in parts per billion. So that's 1,000 times more. And that's equal to 1 second in 32 years. Again, even parts per billion are very tiny amounts, and it's challenging to analyze and measure these. So we should always remember that just even the numbers that we're tossing around, we have to pause and think about what they mean, and we have to understand that learning those numbers, the analytical methods are still challenging, and we should take data with somewhat of a grain of salt. It mentions here that there are limited analytical methods, so how we measure formally and what methods labs use are still being developed, even for PFAS in anything but drinking water. So how are PFAS used? So why are they everywhere? They're everywhere because they are in so many different product categories. They've been used in all of these different sources here. Probably the biggest sources or the highest concentrations are in things like firefighting foams. I'll mention those more later. And obviously in the facilities where these products are made, there are a large amount, or relatively large amounts of PFAS that are being used in those industrial facilities making these kinds of products, or of course in the facilities that make PFAS, there are large amounts. How are we exposed to PFAS? People are exposed to PFAS. The greatest exposures are in those companies, in those businesses that use PFAS in large amounts. So workplaces where PFAS are being manufactured or are being used to do coating of metals or plastics or fabrics, or mixing other chemical mixtures, surfactants, and other things too, where large amounts of PFAS are used. A whole different level of exposure, considerably less, are the other three mentioned here. Food is, FDA has been looking at PFAS for a number of years and doing tests, and generally the food supply is pretty low in PFAS and not considered to be a significant concern, but it is a source of PFAS for the general public at very low levels, but again, not considered at this point to be a general health concern. Ingestion in drinking water has gotten a lot of attention, and there's been a lot of focus on setting drinking water standards and treating water where there are high levels of PFAS. And then exposure from consumer products is another way we get exposed. So if we're using lotions like sunscreens in the past and other lotions and waxes, car waxes, things like that, those all have or a lot of them have contained PFAS compounds. And because PFAS is in carpet and furniture treatments and other places and products in the house, indoor dust is a source of PFAS exposure. So there's a lot of places we can pick these up. This excellent diagram from the American Water Works Association shows, how PFAS move around from all our different uses and get into various different waste streams and into the environment by different things. I think a key to understand here, to focus on, is that there are industries that are using PFAS, and when those discharge to a wastewater facility, or if they just go discharge into the air or into dump sites or something near their facilities or into the water near their facilities, those are going to cause large industrial discharges of PFAS. If it happens to go through a wastewater facility, then you can have some going into biosolids or into landfills with the biosolids and into rivers with the effluent from the wastewater treatment plant. So I recommend this resource, that AWWA document that we have the link to there. When it comes to health impacts, if you read the literature closely, there are always some hedging of what the health outcomes are. There is certainly some well understood health effects, and how significant or how severe they are is there's still uncertainty about that. And then there's uncertainty about possible linkages to other health outcomes. So this is an example of a conclusion from one study. The impact on public health is unclear, but the global exposure to PFAS warrants further investigation. That's kind of a typical research conclusion. If you look closely at the ATSDR, this is a CDC, a branch of the CDC, US CDC. This is the kind of language that they use regarding the health outcomes. What are shown here are the things that people tend to agree on. These are the potential health outcomes from PFAS exposure. Probably from high levels of PFAS exposure and probably not typical kind of background levels, but increased cholesterol levels to some degree, changes in liver enzymes, decrease in birth weight, decreased vaccine response in children, increased blood pressure perhaps, and increased risk of a couple of different cancers. There have been other cancers that have been ruled out, even from high exposure to PFAS. But what's important here is that even this prestigious health and epidemiology agency is saying that they may lead to the following, and they emphasize the word may. So there remains some uncertainty, but we're not experts on the health and government, so we can't comment any further on this. But I think it's important for farm families and others in our communities to understand that the kind of relative risk of this PFAS concern versus others. Doesn't mean we don't pay attention, but it's I think reassuring to know that this is not the sky is not as falling as hard and fast as some other health risks that are out there. So most of our exposure is through use of consumer products. FDA testing has shown little current concern over food quality generally. There is concern if drinking water and food are contaminated at high levels by industry or firefighting activity nearby. The fate in the soil, we do know some things about that. Long chain PFAS like PFOA and PFOS will stick in the soil more, whereas shorter chain so-called PFAS will migrate. So some of them move with water more than others, and some go to groundwater more easily than others. Same with plant uptake. Some will go into plants more easily than others. Testing so far has suggested that for the major known PFAS, there's not likely much uptake into corn. There is a little bit into grass, so that can be of some concern. Seems minimal in most vegetables, except some leafy greens. So there's some variability. And the so-called precursors play an important role. So those are larger molecules that will break down and leave behind your concerning PFOA and PFOA-S and others. So here's a key point. There are two different major sources of how PFAS get into the environment. Most of the PFAS concerns that are raised nationwide, worldwide, are related to significant large industrial discharges of PFAS into the environment, or the use of firefighting foams that are used to put out fuel fires and so they're widely used at military sites, airports, and training has used them and put them out into the environment. And these firefighting foams are very good at putting out or containing jet fuel and other petroleum product fires. So they're actually required, and there are certain specs for them in military specs and firefighting at airports. So these have gotten into the environment in many places, and there's very large contamination situations. And these industrial discharges and firefighting tend to leave behind contaminated sites where you'll see thousands to up to millions of parts per trillion in groundwater or surface water nearby. So these are really big contaminations. These are ones that are definitely getting attention, and deservedly so, because risk can be reduced a lot by treating that water and addressing those sites. When we're talking about biosolids, most biosolids, and wastewater in general, and other sort of waste streams like just our household trash, what goes in the landfills and all that, we're talking about kind of background ambient levels of PFAS. And there's really a big difference in terms of the scale of the PFAS here. So these are all where PFAS have gotten into these waste streams, not because the managers of the waste streams introduce PFAS, but because the waste streams bring the PFAS. These the management of these, the wastewater facilities, the landfills, they're receivers of this ambient background PFAS. And when these materials are recycled, the background PFAS goes along with them, and they tend to cause, hundreds or tens of parts per trillion, or hundreds of parts per trillion of PFAS in waters, groundwater or surface water nearby. So there's really orders of magnitude difference between those big industrially impacted situations where there's large discharges versus what is in most of these biosolids, septage, and solid waste streams, leachate. So here, just to set context, here's a background type study similar to what New Hampshire has just done that Anthony was talking about, but this was done in Vermont a couple of years ago. And again, random sites chosen, not near industrial or known impact, and PFOS was found in every sample, just like Anthony mentioned in New Hampshire. So it's the one that sticks around and it shows up. It was widely used in many places, many products, so it's around everywhere, and up to 5 parts per billion in the soil. So again, that's sort of background. Wastewater and biosolids contain PFAS, of course, as I've mentioned, because because these are part of our daily lives. So things we're washing down the drains and all that, some of the products we're putting on us are washing down the drains, sunscreens, carpet treatments, furniture treatments, things like that all get into the wastewater, even if there's no industrial input. And there's been testing to show what kinds of ranges there are in different organic residuals, so composts and biosolids. And this chart just shows at the top there the levels in backyard compost of leaves and grass, no food waste in it. They're measurable small levels. This is again in parts per billion, and when we're looking here at the bottom, so these leaf and grass backyard composts have them in the low single, maybe up to 10 parts per billion of these various PFAS compounds. And then when we look at food waste with compostable food serviceware in them, so these are composts made with some of the packaging of the food getting into the compost as well, we can see that we get up to like a 50 parts per billion total PFAS, with PFBS, that's a short chain version, dominating. And then there are certain non-biosolids fertilizers that have a little bit of PFAS measurable, and then the biosolids fertilizers here at the bottom are the ones that have the most. But again, they're in the less than 100 generally parts per billion total PFAS. And then these ones up here are non-biosolids, and there's a difference, but they all have PFAS. So what are the concerns on farms? Really, the only concerns with using biosolids or compost or other organic residuals on farms and applying them to soils and homes and gardens and such is the potential for leaching to groundwater and a little lesser risk of plant uptake. It's been shown pretty clearly that inhaling, the odor off of biosolids or compost, or even eating a little of that, inadvertently or whatever, that's not a major source of exposure. It's not a real concern. So the concern is leaching of some of the PFAS to groundwater impacting the groundwater and drinking water in particular. That's the biggest concern. Again, the lesser risk is some plant uptake, which could cause food products to be contaminated. And again, that's not considered as big a risk as the leaching of groundwater, and has not gotten as much attention. Now, there may be other sources of PFAS on farms other than biosolids and compost and organic residuals, but at this point, we don't know enough, partly because manufacturers keep secret about their products and have in the past. So it's kind of hard to know how much, if any, PFAS were used in pesticides or herbicides or other farm chemicals. Likely some were. PFAS was probably a minor ingredient as a surfactant to help the chemical spread in some situations, but we just don't know at this point. There are other places where PFAS might show up in farm chemicals used around parlors and barns, such as cleaners and waxes and other things like that. So there could be localized impacts around barns and milking parlors and machine shops and such where PFAS have been used. But out in the fields, probably at this point, what we know is that the biosolids and other organic residuals applied are probably the likely largest source. So looking at some particular data, and again, trying to give you a sense of context, farms that have been in the news most recently, and back to 2017, the Stone Ridge farms, here are the kind of soil levels and milk levels that were found, which raised concern. And these are related to PFOS. And PFOS, again, is the largest concern. It's what is focused on in most situations because it seems to be ubiquitous and seems to move up into dairy and food chains, perhaps. So soil levels, here we are up in the upper hundreds of parts per billion. It's the highest level on that particular farm, and the milk was affected up to 1,000. The Maine very conservative standard in Maine is for screening of milk is 210 parts per billion, as I show here at the bottom. On the second Maine farm, this is in the Fairfield area, hundreds of parts per billion in the soil. There was some PFAS uptake into hay, minimal in corn, and the milk got very high in a couple of tests. So these are a concern, and this has had major impacts, obviously, on that farm. Very unfortunate. For comparison, there are tests around Maine and many other New England farms where biosolids have been used for many years because testing wanted to be done, right away to see if this kind of impact was being found at other farms. And all these other farms, soil was found to be at, around or less than 10 parts per billion. So elevated above background perhaps, but not a lot. And the milk was all well within the screening value. Because of the concern of the farms in Maine, there's been a lot of testing by the Agriculture Department to look at milk quality overall, and they're finding very low to non-detect levels. So the milk supply is safe and healthy. When you look at biosolids that are not industrially impacted, so compared to those two farms in Maine that I mentioned earlier, these two, we look at farms where there is not industrially impacted biosolids being used, and these are the averages we see in testing that was done in 2019. So the mean in the soil for PFOA was 3, and the PFAS was not about 9. And this is again multiple years of biosolids application at these sites over with typical biosolids, not ones that had high industry inputs. Here's a situation of septage. It's not necessarily industrially impacted, a farm field in Vermont. And again, we're getting some elevated levels in groundwater. But in this testing that Vermont did, there were only a few long-term biosolid sites showed levels of any potential concern. Testing when we look at farms across the state that have used biosolids for many years. And these are far lower levels that we're seeing even in this sort of almost a worst case scenario here shown with these in this map on the right. These levels, the highest is 176 parts per trillion in groundwater. So, it's above drinking water standards, but it's not in the kinds of thousands and tens of thousands and up to millions that we see with industrially impacted worse situations. And in these Vermont studies, there was no significant impact on farm products. So, that's somewhat reassuring. Here's an industrially impacted biosolids that was used on farms in Marinette, Wisconsin. And there was impacts found to 7 of 98 drinking water wells around the farm. So that is concerning. But there was only one result that was above the health advisory of 70 parts per trillion. So yes, when there's an industrially impacted biosolids being used, then you may see elevated levels. But again, we're not talking about thousands or tens of thousands or millions of parts per trillion, even in those situations. So how can you know if there's a problem? Well, again, to summarize, typical background biosolids have single to tens of parts per billion of PFAS. And typical soils where biosolids have been applied for many years have those similar kind of levels. Drinking water, the advisory level from EPA is 70 parts per trillion. So again, parts per trillion. And that's a good standard to kind of compare to. Maine and Massachusetts have 20 parts per trillion for 6 PFAS added together. Those are some of the lowest standards in the world, maybe the lowest standard in the world for drinking water. And so that's another number to compare to. If you have numbers in the hundreds or higher, you might begin to try to understand what's going on, have some concern. Numbers above regulatory limits will mean that actions will be required. So just to quickly finish up, New Hampshire, Vermont, Massachusetts, and Maine have set stringent drinking water standards. Again, some of the lowest in the world and certainly the lowest in the country overall. Maine has set screening, is the only state that set screening limits for biosolids. And these are, pretty protective, very, very conservative. What we found, Michigan has gone about things a little differently from Maine. They focus on source control and pretreatment, voluntary efforts to reduce the amount of PFAS in biosolids. So what can we do? I want to stress that, I'm certainly no health expert, and I don't think we can say we are, but we do need to give try to give some context, and I keep trying to figure out how to say this right. But this is not a huge immediate dire threat. In other words, it's not a sudden impact thing. This is chronic. If there's any health impacts, they're kind of chronic long-term. You and I have been exposed to PFAS, have had them in our blood for decades, if you're as old as I am, or years if you're younger. Any health impacts will be long-term, low level, and are subtle and chronic, meaning not immediate. Some PFAS have declined in us already. PFOA and PFOS have been phased out, so they're already down in our blood by 70% or more, according to the CDC, real measurements. It does go away if we reduce our exposure. So taking thoughtful steps to reduce exposures and any potential risk is a good way to go, now that we know what we know. So one thing you can do is to evaluate and reduce exposure sources in your life and on your farm. We can tell farmers this. Think about the products you use. Know the level in your drinking water and treat or find different source if necessary. Avoid food packaging and other products that may contain PFAS. If you're worried, go ahead and test your soil and possibly hay and perhaps other farm products for peace of mind. If elevated levels are found, then there is increasingly available assistance, including monetary assistance, to help address the situation. And then think of 2 different separate risks for a farm. And one first is that those health and safety risks. So those are primary. Take steps as described above. I like to think of this as, at this point, that we can, I think, kind of say that the risks from health effects from this kind of exposure that we're seeing, for example, even at the Maine farms, is probably similar to driving a car for a bunch of years. Maybe a little more, maybe a little bit less. I don't know. Haven't seen any data on that, and it's maybe hard to measure. But it's likely far less risk than smoking, or opioid addiction. You know, those are things that that clearly kill people, and reliably so. So, but you know, we need to pay attention now that we know what we know, and we can reduce exposures and risks in reasonable ways. So you have to look at that. But then the other thing that farmers should look at is their customer perceptions. And of course, farmers are thinking about this all the time. The regulations and policy and media coverage have set public expectations about PFAS. So there's a bit of fear out there about them. And those perceptions alone, whether they're justified or not, will impact the confidence in your farm products. So talk to customers and see what they think. You know, are they all freaked out about this, or are they, you know, okay knowing that there could be a trace of PFAS in the products they buy, the hay or whatever? Likely, it's not going to have a significant impact on their situation. So, but know that Maine and New England have the strictest standards anywhere, all told, and there's context other states that aren't going as far. So with that, I'm going to turn it back over to Janine, and we can get into questions and such. Thank you all.
Thank you, Ned. I just have one more slide here, which I'm going to share with everyone after the fact, that has some good selected resources to help you talk to farmers, get to know the latest research. So we'll be sharing these with you after the fact, but let's get to some questions. There was a question in the chat for Anthony. What analytical method did you use for data collection, and has that changed as the development of the EPA method 1633 has been occurring? Talk a little bit about that.
So for solid soils, we've been using LC-MS using isotope dilution, which is very similar to CMA 1633, which is about to be passed by EPA for the PFAS solids matrix. When I talk to Alpha Analytical, they tell me that they are conducting the method as close to that method as possible, but I am going to be having a conversation with them this spring to ensure that they are meeting that new method that we are going to be having hopefully passed here this year, as we keep updated from EPA. It sounds like by the end of the year. So at this point, that's the method we're using for solids. Hopefully that answers that.
Yep, thank you. And there was another question earlier about, and this was something I had noticed, the difference between the PFAS in Class A and Class B products, although it seemed to diminish a little bit. But can you just talk a little bit about what you're finding, the differences? Is it short chain versus long chain, or just what's going on with that?
So what we're seeing in the sense of what I showed earlier was that the oxidation that is occurring from certain sludge treatment processes is cleaving the precursors into terminal compounds. So when we measure Class B, our Class B biosolids typically are anaerobically digested or lime stabilized. The lime stabilization doesn't have as much energy or oxidation energy maybe as in vessel compost does. So that's why we're seeing potentially lower concentrations in the Class B versus Class A. Now, that is not to say that it's not there. So that's something we need to still look at is, you know, what is the total PFAS in the material, in the sense of there's over 4,500 versions of this compound. So we want to make sure that we're seeing that. Our most recent collection system data sampling effort, we did top assay on every single sample we took. Working with Vermont DEC, they did that on one of their collection system sampling efforts. So we wanted to mimic that, and we're excited to hopefully get some reports back in a couple of weeks.
Doing some great work over there, Anthony. Thank you. Jose Dion, I have allowed you to speak and start a little conversation here about this international trade we have going on with biosolids. Did you want to make your comment or question? We can do it live. I can't hear you, so you might be on mute on your end.
Do you hear me?
Ah, There you go.
Okay, so I can read out loud what I wrote to you. So
Yes.
it's not really a question, it's more a concern I have. So when it comes to exporting biosolids to Canada, the PFAS issue is only starting to get to the general public here. In Quebec, it's particularly about Lake Menfremagog. And I think if the general public come to hear that USA is exporting biosolids because Americans are concerned about contamination on their side, so they're shipping that to us, there might be some backlash. So I think the site highlight the needs to have local solutions, which will be also more environmentally friendly since it's less trucking, less GHG emissions. So I think the presentation today was really useful in that sense, since we need to communicate better, find solutions to the problem, and take the issue seriously, and have open conversation with the public so they can trust us on this. So thanks all for what you presented to us today.
You're welcome. And you bring up a good point. We do need to continue to talk about the benefits, especially the climate benefits of having this local way to manage these solids. There's a question here from Jason Randall in New Hampshire. What are the regulatory impacts, FDA and public perception of anything greater than 0 in PFAS in farm products? How does PFAS transfer from fields to animals? That's eating the hay generally, we think. Have there been any studies on transport?
Yeah, so there has been research on plant uptake and transport of PFAS through groundwater and into plants and through soils and such. And again, it's ongoing. So there is some plant uptake. Again, as I mentioned, the state of Maine, especially, kind of identified hay as a potential for some uptake. They are focused on the concept that there can be uptake in hay, which then, if cows are ingesting large amounts of that feed, then it does. PFOS in particular lodges into cows' tissues, into meat, and gets into milk. So there can be a cycle. Then the manure then has PFAS in it, and that can cycle around. If they're using manure as a soil amendment, then the PFAS remains in the system and loops around. That usually that only happens though on farms or places where there's a lot of PFAS was introduced through industrially impacted materials being applied, or just in firefighting or industrial discharges on the farm or near the farm. I hope that answered Jason's question.
And here's a really interesting, good question, Ned, for you. Any difference in PFAS in almond milk versus cow milk? Is there any research out there on that?
I think somebody must have seen me drinking my chocolate.
Not out of fear for PFAS, I hope.
Well, I don't know that I've not seen any data. I don't know that almond milk has been tested versus dairy milk, but anyway.
I'm interested now.
Yeah, I don't know what the uptake in almond trees is.
All right, folks, any other questions? You can raise your hand if you want to get in a last minute question here. Otherwise, the one last question was whether we would be sharing this recording. Yes, we will. You can view it later. It'll be available on demand for NEBRA members, and we'll share the slide deck with you as well. And that'll have links to some of those, what we think are really good resources if you have questions about research, regulations, health impacts, that sort of thing. So just to sum up, and first of all, let me thank all of our speakers. You guys, thank you very much for your thoughtful presentations and all the work you put into that. farmers understandably have a lot of questions about PFAS and biosolids, and we need to be able to speak to them. You know, when they ask, should we stop applying biosolids? You can say, it's your decision, but here's what I know, and give them some information. And in the end, it will be the farmer's decision based on their own very individual perception of risk. But talking through these questions and concerns about PFAS has unfortunately become part of our job now. And I hope we've given you some good information, some tools and tips, and we wish you all the best in having these conversations in the future. Thanks for joining us today. I'll get this out to everyone who registered next week. Have a great weekend, everyone. Thanks again to the speakers.
Thanks, Janine.
Thank you, Janine.
See you guys. Just saving the chat and then I'm going to get out of here. Oh, and I want to